Hey, welcome everyone to day 3 of Shelly for Demo Day 2020. I'm Abhijit and thank you everyone for joining us in the live Q&A room of Nirvana Energy System. So what a great demo day it has been. What a great effort by all the startups. I hope everyone enjoyed the show. So this is a live Q&A section. This is where you get to ask the questions to the startup founders. If you wanted more information on their pitch, here is the place to ask for it. If you want to know about their future plans or want clarification on their business model or go-to-market strategies, this is the perfect platform to do it. Or if you just want to drop a comment of encouragement or even say hello, you can do that too. We have the next 45 minutes with the startup founder of Nirvana Energy System. Let's get started. If you have any query, any questions, please write that in the Q&A box on your web browser. In the room today, we have currently Dr. Bart Hesselink, founder and CEO of Nirvana Energy System. Bart was born in the Netherlands, went to the USA under Fulbright sponsorship to study at the Caltech, where he obtained a PhD in applied mechanics and physics. His areas of interest include renewable energy, optical IT system, and 3D imaging. He's also a member of the Royal Dutch Academy of Arts and Science and a fellow of the Optical Society of America and the SPIE. He worked on the Hubble Space Telescope Repair Committee and co-designed the Astronaut Memorial, among other distinctions. He has founded 3 startup companies and was also a former CTO at Western Digital. Hey, welcome Bud to the live Q&A.
Thank you.
Before I start with the live Q&A, if you could let our audience know a little bit about Nirvana system briefly, and then we'll be quickly jumping into the Q&A from the audience.
Yeah, thank you. Thank you for inviting me here to talk about Nirvana. Nirvana is a company that started about 7 years ago. And the basic idea was that I was at a party and I met one of my colleagues, a former dean of the School of Engineering, and he was working on solar panels. And so I said to him, well, if you want to work on renewable energy, you really should work on concentrated solar. And he said, well, maybe that's what we should do. And so I set out to try to find out what that system could be like. And it turned out that you need a heat engine. And so one of my former students was a director at NASA Houston. I called her up and I said, seems like NASA is doing a lot of work on the Startling engine, so where should I go? And she said, well, I'll call you back in a few days. And she did. And she said, I have to go to Cleveland, Ohio. And so to the Glenn Research Center. And I did. And so I said to one of the managers there, NASA just spent about $100 million on a 1 watt or 100 watt system. So that's $1 million per watt. And I would like to use this technology to build a system for homes that's probably going to cost $1 per watt. So I figured they were going to knock me out of the door and say, never come back here because we don't do that work. And I said, oh yeah, that's possible. So I then started working with NASA. We hired some NASA engineers and then we started Nirvana.
Great, great, Bert. We just have our first question popping up here. So how does Nirvana fit into the entire energy ecosystem?
So the system that we have is based on a Startling cycle. So the Startling engine was invented 200 years ago, but it's a mechanical system. And therefore the reliability and the cost is high. And so what we set out is to do something that is much lower cost, so that it could be utilized as a combined heat and power system in the home. This is totally standalone, so it could be if you're off-grid or it could be connected to the grid. When we were working on this for a while, it turned out that because of the fact that the Thermo acoustic engine that we built is much more responsive than the conventional Startling engine, we could actually, as part of our architecture, involve solar and wind power directly. And Then you can think about our thermoacoustic device as being a load-following device that would make certain that when the radiation of the sun is changing or the wind is changing in its speed, that the engine instantaneously responds to it and provide a fixed frequency and a fixed voltage to your home or to the network. And so as a result, it's what we call making these variable, uncertain, but renewable energy sources dispatchable. So we think that it has a role to play in providing electricity and also heating, but you can do that very efficiently by using solar power. The other alternative is to use more batteries for solar power, but we know that the problem with batteries is that A, they don't last forever, and B, they're very expensive in terms of kilowatt hour cost. So we think that this is a solution that could significantly improve the usefulness in a networked environment or standalone to make the power that is being generated by these renewable sources more useful.
Right. And there's a follow-up question also. Can Nirvana contribute to reducing global warming of gases?
Yeah, so if you actually look at the reduction in global warming gas, there's different ways of looking at this. One is that the amount of global warming gas that's being produced in the network today, for example, in the United States, can be significantly reduced because we can introduce a lot more solar power. Secondly, if you took a reasonable estimate, and of course this is far out thinking, hoping that this would actually be employed in the world. If you took about 10 or 15% of the global market of hot water heaters and you replaced them with a Nirvana taps machine, then you could get roughly a gigawatt ton of CO2 reduction per year. And so we can potentially see a roadmap to do that from where we are right now by 2030. That is a very significant impact, given that the reduction we need to achieve is on the order of about 40 gigawatts or so. Or 40 gigaton, I should say. That's one way. And it still is using, in that case, gas or some other fuel. If you use nitrogen, of course, then this can be even further reduced. There's another opportunity here, which is something that is interesting, namely that the machine can also act as a cooler. And so it's identically the same architecture, the same structure, but you do not supply any heat to it. If you don't supply any heat to it, the engine essentially is trying to extract heat from the environment and becomes a cooler. So Startling engines are well known to be cryo coolers. And so you could imagine that you could actually cool CO2 to the form where it becomes actually frozen. So you essentially have it in a very low factor. So you could imagine even a system where at the same time that you generate electricity, you can also extract that CO2 that's being generated by burning fossil fuels and turning that into some form that then later on can be either transformed into other fuel or can be utilized for cooling applications or making plastics or other things out of it. So it's a very versatile cycle. A lot of this still is a pipe dream in the sense that, you know, there's a very good technology, but commercializing that is not necessarily a simple and straightforward thing, but in principle, you could do that.
Right. And I can see a lot of people are curious about your solution. And one of the questions that is popping up twice that, you know, can you provide us a little bit more clarity in simpler terms, how your solution works with a combination of solar and wind combinedly?
The question is, how does wind combine with our system?
Right.
Okay. Maybe I should explain briefly how the system works, because then that hopefully will make more sense. So think that you have a pipe, so somewhere about this size and that long. And on one end of it, you have a electric motor that has a piston in it that produces an acoustic wave. And so what happens is inside this pipe, and suppose it's closed on the other end, what you find is that the pressure is going up and down. And as the pressure is going up, the particles inside this pipe are moving either in that direction when the pressure goes up, or in the opposite direction when the pressure goes down. And so as the net result, what happens is that the whole slug of this fluid is always constantly moving back and forth as we create this acoustic wave. Now, if you put in heat exchangers, one of them is cold and the other one is hot, if the particles are moving in this direction, which is, for example, helium as the using gas, the working gas, then there's a temperature gradient that essentially puts energy into the wave, and so therefore the pressure goes up. In the other half a cycle, the pressure actually goes down, and now we go from hot to cold, we extract heat from it. So what you have is a hot and cold heat exchanger essentially produce an amplifier for the acoustic wave. So in the first stage, it might be 2 to 4 times larger. Then you have a second stage, makes it also 2 to 4 times larger. So you now have at the other end of the pipe a pressure wave that is somewhere between 4 and 6 times higher than what you generated. Now on this side, you put the equivalent of the motor, which we call an alternator, which is a piston that moves in a magnetic field. It produces an electric current and voltage. So now I can use that electric current and voltage for the user, but a small fraction of it I put back into the motor. And so now I have a power amplifier, an acoustic power amplifier using any type of heat. Imagine now in the feedback loop, as it is called, I inject solar or wind power. What that does is that whatever power I was taking out to run the motor is essentially going back to the customer. And I can now make this whole system completely responsive in a very short time period, because I can actually control electronically the position of the pistons, how fast it moves and how fast it reacts. So any type of energy in the form of electrical energy can be injected into the system. And what comes out of it is a regulated voltage frequency that comes out for it to use. So it's a very stable energy source, but it's only possible because of the fact that we've invented this feedback loop system that creates this electricity. As a byproduct, you also have a little bit of heat. In the cold heat exchanger, you take that out, so you can use that for your home, for domestic applications. You can get hot water out of it. And then if you now have exactly the same system, but there is no heat going into the hot heat exchanger, then what it will do is it will try to extract heat from the environment, and so now you have a cooler.
Great. Thank you so much, Bart, for explaining about how the solution works. I guess that's quite educational for the audience. So what makes Nirvana's products more unique and desirable, Bart?
What makes it what more?
What makes it more unique?
Well, there's several things. So there are 2 co-founders. We both have I did start 3 companies, and that have been successful. My co-founder probably has been involved in 6 startups and a large number of large companies. I've also been involved in large companies. So the management have a lot of experience. But the most, from a technology perspective, this new architecture that enables an old 200-year-old technology to become commercially viable and has these properties that we can respond very rapidly in an environment, and has no hot moving parts, which are the parts that are associated with a conventional Startling engine. I think that's going to make it possible to get a low-cost, very reliable, no maintenance over 20 years system. And I'm not aware of any other company in the world that's working on this type of a thermoacoustic approach.
Great, thank you. And for those in the audience who have joined us late, this is the live Q&A section for Nirvana. So this is where you get to ask the questions to the startup leadership team. If you want more information on the pitch, want to know more about their future plans, or want clarification on their go-to-market strategies or business model, this is the perfect platform to do it. If you have a question, please write that in the Q&A box on your web browser. We are live with Professor Hesling, founder of Nirvana Energy System. For the benefit of the viewers who have joined late, Nirvana is a spin-off company from Stanford University, founded by two repeat entrepreneurs, Professor Gibbons and Hesling. Nirvana's products use acoustic heat engines to make solar and wind power dispatchable. And we are live with Bert here. But going away from products and moving a little bit to the customer segment. So we have a question here. Who are your customer segment, and how long Nirvana has been in business, and how many customers does Nirvana currently have?
Right. The biggest challenge for a company like Nirvana is to go into the consumer market. When you're in the consumer market, like I was with Western Digital, where we would build 250 million hard drives in a year, you need a lot of capital, you need a lot of production capability, you need a very large infrastructure. So we originally targeted homeowners. So in Europe, around 2000, there was a pretty strong market for combined heat and power systems that would replace hot water heaters. They used a Startling engine, but unfortunately the cost was too high, and also it had maintenance issues. When we started looking into it, one of the things that are important if you've got a product that goes into the marketplace is OpEx, CapEx, and reliability. So we could certainly build to reliability, but OpEx would also be low because of the fact that we can actually leverage solar panels, but the CapEx is an issue. Initially, if you look at this, and I said $1 per watt, that's roughly right. If you want a 4 kilowatt system, there's a price point of maybe $4,000 or $6,000 that anyone is willing to pay. If it becomes much higher than that, then you better buy just a hot water heater for $1,500 or $2,000 and then get that installed. And so the question that we really, an obstacle that we face is how do we go from where we are right now without investing $100 million into a product that indeed can be $1 per watt? And so it turns out there's one market which is not very price sensitive, and that is the remote power market. And particularly if you're in areas where you have cell towers or you have places where and there's industrial activity outside major hubs and living areas, then the problem becomes more a problem of maintenance. And so when you look at the remote power in developing countries in Africa and also in India to a certain extent, remote villages have a real issue because they have IC engines. IC engines don't last forever. And so the cost of maintenance becomes the biggest problem. And flying in crews to kind of do this to remote sites is extremely expensive. So when you look at the total cost of ownership, or if you look at the levelized cost of energy, which is the total cost of the energy divided by the amount of energy that you generate, it turned out that we have the lowest cost available. And so, and we can then have the luxury of, for the initial products, charging a order of magnitude more than what we would do for a consumer product. And so our first target has been to go to the remote power market. And that includes containers that might have these devices in it. It can be local area networks that produce energy, micro systems. And we are working with one of the largest companies that in terms of market share in the world, and they have been testing our products. And so we expect that our product probably can be on the market in about at the end of next year or maybe 2 years from now. The other part of the question is how long have we been in business? We started in 2013, so it's almost 7 years.
All right. And you mentioned launching in 2021 or 2022. So there's a question from the audience. Have you conducted any pilots so far?
Yeah, we did. We actually conducted several pilots, and one of them was with this company that did do a lot of testing over a significant period of time, and the and the feedback that we have incorporated that in the latest version of the system. We have probably built on the order of 5 or 6 prototypes each time, making changes to what is architecture. The architecture was the same, but specific details of how the components that I described are being manufactured. We've also spent a lot of time designing this for manufacturing and trying to bring the cost down. So there's a lot of work that needs to be done in order to develop a new technology. I mean, we heard that a little bit earlier in the introduction for future technologies from this team from Shell. It's not a simple job. You have to have a lot of perseverance in order to be able to make this work.
Right. And there's a follow-up question on the product portfolio. So does Nirvana have a strong patent portfolio? And what is your IP strategy, if you'd like to share, and how do you protect it?
Well, we have, I think, about 9 or 10 patents, and some of them are very fundamental architecture. So it's kind of unusual after 200 years to essentially have a whole new architecture and be able to patent that. But we were able to do that in conjunction with some collaborators that we've had over the last few years. And so my experience, though, tells me that patent protection, which is a very important question that always comes up in terms of investment into a company, in practice is a very different animal. And the problem is this: if you're a small company and you actually wind up in a lawsuit, then essentially you're going to die because at $1,000 an hour, you can't afford any good lawyers. And you can also not afford to kind of have your technical personnel and deal with all of the issues that come up when you're in a lawsuit. So as you start and you develop your product, the patent portfolio is really not that important. Now, if you become successful and you essentially become a threat to others in the marketplace, then those companies may go after you and they may try to make, either through legal means or other means, trying to copy what you're doing. Well, if you're very successful, you might have enough money to kind of fight that and deal with it. But more importantly, most likely what is going to happen is that in order to be successful, your IP strategy isn't going to be the one that is going to make that happen. Your business strategy is going to be the one that is going to make it happen. So if you're the first one in the marketplace, I mean, look at Tesla. Tesla was the first electrical car that had a major impact. And there's BMW, there's Volkswagen. All these companies are now going to go build electric cars. If you look at the volume, Tesla is the one who's getting it. So there's 80-20 rule. So 80% of the market shares is given to only a very small fraction of the companies. So in order to be successful, you've got to be fast and you've got to be the first one to get into the market. And then, yeah, the IP strategy helps, but if you have to fight it out in court, big companies like IBM have so many patents, they would always try to find a way to kind of block you in. So we have a good patent strategy. I have a lot of experience with patents. I've been a patent expert in many, many cases. And so I learned from that, but that's not a strategy to really build a company.
Right, that makes sense. There's a question coming from the audience on does Nirvana have any competitors? And if so, then how are you different with respect to them?
Competitors, well, if you think about making solar and wind dispatchable, the current technology is batteries. Now, the problem with batteries is that you can't have enough batteries. So in California, for example, if you look at the weather patterns, it can take 9 days or 10 days of rain or snow in the mountains. And so you won't have any power. So there's lots of marketing that takes place. For example, at Stanford University, the official message is that we are 100% renewable energy. Well, but if there's a cloudy day, where is this energy coming from? It's not coming from solar power in the desert. Well, it's coming from some other state, maybe from a nuclear power plant or coal or gas. And so the idea is, yeah, we hook it up to 100%, but it's not what we're going to get. So overall, if you look at the whole system, it's extremely difficult to do that. To get 9 days of storage capacity for a state as California, it's not economically feasible. And so we have probably the largest amount of storage in some of these energy providers, and it's 4 hours. So after 4 hours, right, you've got to do something else. Right? So we think that our approach is a better approach, because also the amount of energy that needs to be put into making batteries, etc., is quite significant, and the lifetime is limited. There may be 7 or 8 years, or maybe 3,000 or 4,000 cycles, so depending on how much you use. So I believe that for quite a long time, some form of heat energy is going to be necessary in order to make solar and wind useful. And I think batteries are going to become a problem. And secondly, if you have a large number of electric cars, where are we going to get this power from? Now, the estimates are, for example, that in California, we have to roughly get 50% more electricity generated than what we do today in order to convert our water heaters to electrical heaters and otherwise. So I think there's a lesson to be learned here is that if you want to look at solutions, you've got to look at the solution from a systems perspective, not just from some components or subsystems that go into it. So in that sense, I don't know of any other company that is doing this, although there are some research programs that are Brayton cycles and other devices that also heat engines that provide this storage. And of course, you can also store energy in the form of heat and then use another heat engine to kind of create electricity again. But I think that there's going to be some hybrid approach. And so in that sense, we kind of have a unique opportunity here.
Right, but you also mentioned that Nirvana's product makes solar and wind energy dispatchable. Can you please help explain our audience what does it mean by this?
Yeah, dispatchable means that if the load that you're trying to drive is varying over time, that you then can make sure that your energy source is providing that energy at any instant of time. So if you connect a device to the network, so your home outlet, the electricity grid is capable of instantaneously providing whatever power you demand. If you put in your hair blower, dryer, it will provide about 1 kilowatt of hours power. If you take solar panels, they don't do that. So if I have a solar bank, then what's going to happen is that I get a certain amount of energy over the day. It is going to go up and down. And but then instantaneously, if there are clouds or if something else happens, you may not get that. So somewhere in the system, you have to have a storage capacitor for energy. And so batteries would be okay, because they can react very quickly. But the problem is that at night, so if today now in California, it's dark at about 5:30 or so at night. And so till about 10 or 11 or 12 where I'm now, is 7 hours. If I had 4 hours of electricity and the demand is high in the evening, I don't get any power. So I need to have much more storage than few hours a day. I need probably have 3 or 4 days that I can work from the batteries. Well, when you look at that system, it becomes prohibitively expensive. So our system then is that storage device that, using an external heat source, so it could be gas, for example, and that's our first approach to take. That system then allows you to take whatever solar power that you ever create and always augment that at exactly the time when you need it with our system, the tap system, so that you get useful power. So that's what dispatchable means. And that's what also the utilities are very interested in. And you may notice, but the utility grid around the world cannot take more than 40 to 60% solar power, just because of the fact that everything is fluctuating. So what used to be the problem is that you had a demand and that was fluctuating, but the source was always available. So you turn your diesel generators or gas generators on. That problem you can solve, and that's what we've done for 100 years. Now what we're saying is okay, we have varying demand. I'm plugging in my Tesla into the grid, and at the same time, I'm powered that I don't know if I will have it. That's the big problem. And so our system essentially says, no, we can solve that. We can give you solar power combined with ours that is going to be always available when you need it.
Great, that is quite interesting, Bert. And again, for those who have joined us late, this is the live Q&A section going on with Nirvana. This is where you get to ask the questions to the startup founding and leadership team. If you want to know more about their business model, the future plans of the startup, and their go-to-market strategy, this is the perfect platform to ask for it. Or you can just drop a comment of encouragement or even share hello if you can do that too. So if you have a question, please write that in the Q&A box on your web browser. Currently, we are live with Bert, founder of Nirvana Energy System. So, Bert, there's a question from the audience that we do understand that Nirvana does not only develop electricity generation system, but also cooling systems. Could you further elaborate on some of these projects by Nirvana?
Yeah. So think about medical vaccines and others. So the coronavirus is obviously a pretty important example. Some of the vaccines that are going to come on the market, for example, the one from Pfizer, require that you freeze the vaccine at minus 80 degrees centigrade. Now, your refrigerator at home operates at maybe -4 or something like that, centigrade. So between that temperature and minus 80, there aren't very many cooling techniques. Your air conditioner is not going to get there, and your cool box at home is not going to get there. So the technology that is being used today is a technology based on Startling engines, Startling coolers. And so that's the same technology I described earlier, which has mechanical systems in order to carry out the Startling cycle. But they're expensive, bulky, and they require maintenance. So our system can do exactly the same thing with this new Startling cycle, but using thermoacoustics. And so using that system that I just described, instead of putting heat into it from fossil fuel or from something else, you essentially extract it from the vaccines. And these cryo coolers, as they are called, they can go to a much lower temperature than the minus 80. And so, which is roughly on the order of about 190 degrees Kelvin. You can go less than 55 degrees Kelvin, which is the temperature where nitrogen becomes liquid. And so you have a very, very cold environment. So cryo coolers have been on the market for decades. They're used by the Navy and by other places, but they are expensive. And so we believe that a product that we have currently under development could be utilized for the supply chains from vaccines to deliverable. And they could also be utilized for other applications where you want to bring down gases into liquid form or into some forms that you can transport them. So I think cooler market is a very interesting market. The device itself is much simpler. It doesn't require any external energy. The cost is much, much lower. And so we think that that's a very promising application. And we hope that that will come on the market sometime next year or early the year thereafter.
So, but then how do you compare Nirvana's proprietary Thermo Acoustic technology to conventional Startling engines?
So the cycle is the same. So there is a cycle in which when I compress the gas, I add heat to it, and when I expand the gas, I extract from it. It's identically the same in the mechanical system versus the thermoacoustic. And sorry, in the mechanical system, you have lots of leverage and you have pistons. And one of the key problems with it is that there is one part of the cycle that essentially goes like this. I have a chamber, gas is being compressed, and then I take that whole slug of gas and I push it into another container, and then I add heat to it. This transfer of the gas, the slug of gas, from one container or one bath, as we call it, to another one, essentially requires the movement of a hot set of displacers. And so they have to be very accurate. They can't have any losses or very small ones, and it's very difficult to manufacture them. So the whole system becomes heavy. It's more difficult to maintain the performance. It's expensive to manufacture it, and it's never been successful. All of that goes away because in the thermoacoustic case, instead of moving this slug of gas by a mechanical piston that goes back and forth, we just essentially have an acoustic wave that goes through this gas, and it moves the particles back and forth. And then we can extract heat and add heat to it depending on what the cycle is. So much simpler, much easier to build from a mechanical perspective. And it has very fast response with the conventional cycle does not have.
Right, but there's this question asking about but according to you, as you have huge experience in this domain. So, what are some of the skill set and competence you envisage the folks should have to work on such kind of technologies?
I'm sorry, you fell away for a few minutes here, or seconds, I should say.
So what the question is, what are the skills and competence that people should have to work on this kind of technologies? So what kind of team, you feel is perfect to work in this kind of domain and technology?
Oh, you mean what competence that somebody, what knowledge somebody would have? Okay.
Right.
Well, first, the most important thing is you've got to be interested in it and like to do something new. So assuming that you have that, then, physics background. So my background is actually in physics, but also mechanical engineering. And then mechanical engineering, particularly fluid mechanics or acoustics, is a very helpful knowledge to have. But there are a lot of aspects to this. So there's heat transfer, there is the stresses and strains, mechanical strengths in the total system. Then there's electronics, there's essentially a feedback loop, so control theory is important. So there's a series of different types of expertise that we need to get on board in order to be able to do this. And then there's lots of numerical modeling. So one of the great things about this device is that it's largely a one-dimensional problem. And so we can actually solve that using the Navier-Stokes equations. And so anybody who has a good understanding of fluid mechanics and acoustics would be extremely helpful to have on this project.
All right. I hope that answers the question from the audience. And in the current situation of coronavirus, so how has this COVID-19 affected your business? Was there any positives, any negatives? Was your business affected?
Well, it depends on whether or not you're an optimist or a pessimist, right? So if you're an optimist, you say, wow, here's an opportunity to build a cryo cooler that can transport billions of vials of vaccine. So if you're a pessimist, then you say, yeah, but the supply lines for the components that go into the system have been delayed. Transportation is a big problem. Getting things done on time is a big issue. People sitting at home and not talking to each other live may be an issue. So I think there is, from an overall performance perspective in terms of efficiency in the business, I think the coronavirus has definitely been negative. But you know, my sense of the world is that it doesn't really do you any good to talk about all the negative things. You might as well think about the things that are exciting and that come ahead of you. So, so I see this as an opportunity. I think that you know, cooling is probably going to be the most important thing for many people around the world. If the world is heating up, you know, having the cooling capability is going to be an extremely important one, and so that's what we can work on.
Hey, those are some positive vibes. And for those, for the audience who have joined us late, we are currently live Q&A with Nirvana, and we have Bert in our room. And we'll start to wrap up, but we'll take a couple of more questions. And if you want to place them in the Q&A box, please go ahead and do that. So, you know, your history with Nirvana. So what has been your experience in terms of, have you faced any failures in the journey of Nirvana till now? And have you done any kind of pivots as a company?
Have I not done any kind of what?
So have you experienced any kind of failures in the company till now?
Yeah, sure. I mean,
And
if you
would
don't
like to share something. Yep.
if you don't have any failures, you don't have any, you don't take any risk. So the whole business about small companies is that, you know, if I compare myself to Shell, right? So Shell at one point had, I don't know, $450 billion in revenue and, you know, billions of dollars in profit, and they could build all kinds of things. I don't have any of that. So how can I compete with Shell? Well, if I have to make a decision, then there's probably an executive vice president and a vice president, and then there are managers. I mean, it's a very large infrastructure that has to make a decision about a significant change in the business. As a startup company, we do it just like that. I can make this decision and it's instantaneously implemented. So the only advantage that we have is that we can be faster in the technology development than somebody who is already established. So that means that you have to take risk. And if you make a mistake, then you just have to correct for that very quickly. That requires that you have an infrastructure that enables you to build things rapidly, rapid prototyping, testing them. If you make a mistake, go do it again. Of course, modeling and all these things are very important as well, but you can't be slow. If you're slow, then it's becoming really difficult because you drain cash. You have to get more and more investment. Your ownership goes down. And so this is the only advantage, really. Technology and very fast decision making. That's why there are still startups in the world. And then if you're successful, you get bought up by some big company who then tries to take that into your and their own structure. So we've tried a number of things that didn't quite work out. They were either too expensive or they were not working exactly as we thought they should work, or there were materials issues. So we've built, like I said, 5 or 6 prototypes, and each time they were better, and we made mistakes and we corrected from them. So now we have a whole arsenal of things not to do, which is almost just as good as knowing what to do. Not to do is like, okay, I don't want to make that mistake for a second time.
Right. And this is interesting question from the audience. What are the other startups you founded? You have mentioned that you have founded 3 other startups. So if you can briefly talk about those.
Yeah. So I had one startup that started in the 2000 area. That was associated with 3-dimensional optical storage. And that company ultimately was sold and went into networking. Then in 2000, I started a company that was essentially like what we do here, Zoom. And so it's called MioNet. And so it means in Italian, my network. And so I could do what you can do here now. We had remote desktop. We had communication technology over. You could share the documents that you're working on. Collaboration was possible. pretty much the same thing as here. The only difference is that we did not store the data in the central database in the cloud. What we did is we gave you a device in your home that you could then utilize yourself, so you had control over that. And so I offered this to Western Digital, and they then put it into all of their remote access capability for addressing hard drives that you might have. And so I could actually do exactly what Dropbox is doing. I could put a file into my location, and then it would actually synchronize that over my whole network. So we sold that to 150 million people around the world. And then this was not really Western Digital's business, so they're still continuing with that, but not in the same way. And so that's why I wound up at Western Digital as well. So, and that was an eye opener to go from a 25, 30 man person, I should say, company to Fortune 100.
It has been really awesome to interact with you today, Bart. And thank you everyone for tuning in. This has been a fantastic demo day. We hope you have really enjoyed it. And remember, if you can access the recordings of these Q&As after the event has wrapped. You'll also be still able to contact the startups via our event website. So go and connect with them. Thanks again, and we hope you have really enjoyed the Shell E4 demo day. And Bart, thank you so much for your time, and thank you so much for answering the questions from our audience today.
Well, you're welcome, and thank you for moderating the discussion and the very good questions from the audience. I really appreciate it.